Hi, today we'll be implementing our own list. So there's three different kind of lists. One is just the general list. Actually no, so we're going to be implementing a general list interface. So there are three different kind of lists. We might have already talked about it. So there's unordered lists, ordered lists, and index lists. So we're just going to be focusing on ordered lists and unordered lists. So just lists have some common methods that are used in both unordered and ordered lists. So we'll see those, and then we'll do the interface for the ordered list and unordered list, all ADTs. So abstract data types. So we'll be using generics again. If you don't know generics, just look back. Should be some notes and stuff. I'll try to get some notes up for this stuff too. So we'll do a new class. It's just going to be called ListADT. I should have made an interface. So we'll just do public interface. ListADT of generic type T will extends iterable of generic type T. And then up here we'll import java.util.iterator. So here we'll just write some javadoc. So we're going to be continuing javadoc and then do the method. So we're going to do a description of the method first. So for remove first, it removes and returns the first element from this list. Return the first element from this list. So public T returns type T, remove first, interface has a semicolon. The next one will do remove last, so we'll say removes and returns the last element from this list. Return the last element from this list. We'll say public T remove last. So removes and returns the last element from this list, remove last. Then the next one for removes and returns the specified element from this list. So you get to pick which element you want to remove, so it takes an object parameter. At param, you could also do returns type T. We'll just do at param element, the element to be removed from this list. We could also say here at return T could say obj, could returns T obj the element removed. We could do the same for this and this. Here we could say at return. Actually, we already said at return. At param element, the element to be removed from the list. we could say TOBJ, the last element from the list. Here we could do the same here. At return TOBJ, the first element from this list. So this one's removed, so public T remove. So it takes a parameter here, T element, or we could say TOBJ. Doesn't really matter. So here we'll do the first method, so it checks the first element of the list, or the object in the list. So returns a reference to the first element in this list. At return a reference to the first element in this list. We could just say returns TOBJ again. Actually, we already have return, so we'll just say TOBJ, a reference to the first element in the list, in this list. So just on a side note, we're going to be using this list interface, ListADT, to implement an array list implementation and a linked list implementation. And within, they're going to extend each other for unordered and ordered lists. So you'll see. It's kind of confusing, but just the way this textbook did it, Java Foundations. Some of the code might be mine, but at this point, it's just a standard interface. It's not really theirs either. It's an open API, so we'll just say here public T remove. Then we'll takes T element. We could have changed this to element. Well, it just returns an object. Doesn't it's the same thing. What's happening with this? Okay, whoops. Right, we said first. So public T first. That's good, and then here we'll do last, so same thing, just returns the last element. So returns our reference to the last element in this list. At return TOBJ, a reference to the last element in this list. So it returns an object of type T. That's all that means. You can even call it OBJ if you want. Then here we'll say public T last. Then here's we'll say the contains method. We'll define the contains method, so returns true if this list contains the specified target element. At param target, the target that is being sought in the list. Pretty much search for. That's all that sought means. So return true. So it's a Boolean method if the list contains this element. We'll say public Boolean contains T target. So really what this interface is just it's like a guide. Mostly a guide, and just saying that the class has to implement these methods for it to be a list ADT. That's all that it's saying. and it tells us what parameters to use and what to return, so it is a little bit useful. It's just like a draft paper basically. And says you have to return these types or these object types and these methods, and it has to have certain methods. That's it. And you can also use interfaces in polymorphism, and that's really all it can do. But so it is slightly powerful because you can use it in polymorphism to instantiate stuff, so it does have some uses outside just being a guide. So here we'll say returns true if this list contains no elements. We'll say at return true if this list contains no elements. This is for is empty, if I forgot to say that. So public boolean is empty. We've seen it before. This will be the size method, so returns the number of elements in this list. Return the integer representation of returns the integer representation of the number of elements in this list. So just public int size. Seen it before. And then just iterator and toString. So iterator can iterate through a collection and return objects. Its methods are like has, next, and remove. And you can use it in a toString as well. I have an example somewhere. So public iterator of generic type T, iterator. Whoops. Up here we will put some doc here, so we'll say returns an iterator for the elements in this list at return an iterator over the elements in this list. At return it's automated. Didn't see that. That's it. So iterator has a few uses. We'll be going over it. Then we'll say returns a string representation of this list at return a string representation. So public string toString, and then we'll put an at override here, so it knows we're overriding the object's version of it, object class, sys version of it. So now we're going to have an ordered list ADT and an unordered list ADT, and they're going to extend this interface. So that's our main interface for ListADT. So all lists are going to have these general methods. So notice we're going to remove first, remove last, remove object T element, remove with a parameter T element. We can check first object in the list, we can check last object in the list, we can search the list for a target object or target element. We can check if it's empty. We can return the size, we can iterate through it, and we can print it out as a string. So notice there's no add methods here. Adding is what differentiates the lists. So for an ordered list, is that the first one? So the first one we'll be doing is an ordered list. So an ordered list adds in a specific way, and an unordered list adds in the way the user wants it to be. I have a definition, an exact definition somewhere. I'll try to get those notes up too. So we're going to have to create a new interface. So a new class, and then select interface, and we'll call it ordered list ADT. So we have public interface ordered list ADT of generic type T, and it's going to extend ListADT of generic type T. So an ordered list is a list. An ordered list ADT is a list ADT through inheritance. So it also has all the same methods as well. Did I miss a general Java doc? Yeah, well, so we'll go back for a sec. We'll go to the ListADT, and like above this we can put something here. So we'll just say ListADT defines the interface to a general list collection specific types of lists. Will extend this interface to complete the set of necessary operations. So ListADT defines the interface to a general list collection. Specific types of lists will extend this interface to complete the set of necessary operations. So that's it. So here we'll have a definition as well. We will have to not import anything. So here we'll put some Java doc. We'll say ordered list ADT, and then not import anything. No, I'm just joking. So then we'll say defines, so ordered list ADT defines the interface. Ordered list ADT defines the interface to an ordered list collection. So only comparable elements are stored and kept in the order determined by the inherent relationship among the elements. So ordered list defines the interface to an ordered list collection. Only comparable elements are stored, so they have to be comparable, and they're kept in the order. I might as well put an and here because it doesn't really make any sense. So and kept in the order determined by the inherent relationship among the elements. So an ordered list has an inherent relationship among the elements. That's what an ordered list is. So there's just one method in here. It's the add method. So we'll just say adds the specified element to this list at the proper location. At param element, the element to be added to this list. Then here we'll say public void add and takes parameter t element. Takes a parameter t element. Save it. That should be it. Then we're going to do the last one, and I'll probably do a 2-part video because it's already 11 here, so it's getting kind of late. So we're going to go over the whole array lists and linked lists implementations with unordered and ordered parts. So it's going to be great. So we have our add method. Then we're going to create a new class here, or a new interface. So we'll call it unordered ListADT. So public interface unordered ListADT of generic type T, and it extends ListADT just like the order list ADT. So we'll say unordered list ADT defines the interface to an unordered list collection. Elements are stored in any order the user determines. So I think there's a trick here. You have to look at the theory. I'll try to include it in the notes, but I think there is an order. There is some kind of order here, but it's kind of like determined by the user, something like that. So it's like a trick question. So public interface unordered list ADT of generic type T extends list ADT of generic type T. Actually, sorry, we already did that. We don't need a constructor, and then we'll just do the method. So under here, we'll say adds the specified element to the front of this list. Add param element the element to be added to the front of this list. So we'll say public void add to front, takes a parameter t element. Save that. Should be any more. Yeah, there's 2 more. So the next one, so you can add to front for an ordered list, you can add to rear, and you can add in the middle. So if you have some kind of data and you're managing it, then you can add to the front of the data, you can add to the end of it, and you can add to somewhere in the middle. So you can say here, adds the specified element to the rear of this list. Add param element, the element to be added to the rear of this list. Then we'll do the method public void add to rear. Takes a parameter t element, or tobj, doesn't matter. We'll do the next one. Add after. Adds the specified element after the specified target. Add param element, the element to be added after the target. Then add param target. The target is the item that the element will be added after. Public void add after takes a parameter t element and t target. So add after is going to it's going to add an element of type t, and it's going to be adding it after a target element of type t. So let's just say you have course objects, and you can look for the course you want and then add it after. Add the element after the object type.